Really, he's got like insurance. He's going to Michigan Saturday. Whereas, like, it's the GPA requirement is like 5.
All right, what do we think about this? How many squares are going to be in pattern number 20? And our part is 404. Does everybody agree, or we have any different answers? I just write them all up here. What'd you get? 81?
Just a guess.
Okay. Any other answers you want to put up here?
Yeah, I got 400.
Okay. Talk me through it. What do we see?
The number in the
Mhm.
middle,
Mm-hmm.
on the first one is 1 by 1, and then the second one just goes 2 by 2.
Yep.
And
Yep.
I took the pattern number,
Mm-hmm.
just squared it, and then add 4.
Uh-huh. I see what you're going for here. We got 3 here. We got 3 here. So we've got, looking at this little piece, the only thing that's changing is this center piece. This piece is growing out in each direction by 1. So it's growing in 2 directions. That's why we wind up with something squared when we're writing our expression. So if we look straight up at the number of squares we have here, just looking at the numbers, here we had 5 squares, here we had 8 squares, here we had 13 squares. If we look and see how it's changing, this one went up by 3, and this one went up by 5. So they didn't go up by the same amount, so I can't say it's my slope. If they go up by different amounts, we're going to look at our shapes, is how we do this. So we do exactly kind of what we were noticing there. I'm not saying this is the only way we can do this. I have seen it done with making the big square on the outside be 2 times n plus 2 times n, or 2 plus n times 2 plus n, and then taking away 4 pieces. I've seen it done in a couple of different ways. So there's not one way to do this pattern, but I feel like finding the centerpiece and then realizing that these 4 guys are the same every time, those guys are the same. So if we're looking for a pattern here, it is indeed going to be our figure number that we multiply by itself. So figure number squared, that was loud, plus 4. I do agree with the 404. That's what I got. We don't necessarily have to wind up with the same exact pattern here. There's several ways of writing statements that are equivalent. I have seen 3 or 4 for this particular pattern that make logical sense. So if you got a different kind of pattern, that's possibly okay. I can look at it if you're not sure if yours works. But if you got 404, it probably works. Okay? So we are going to be in our workbooks again today. Shock. I know. And we are going to be looking at pages 80, and then we should be able to get to 81 as well. I know. To be fair, if we... Oh, yep. To be fair, if we look at page 80, there's a grand total of 4 pieces on it. And 81, I believe, is a grand total of 5. So, it's not aggressively long. So this one is called gasoline cost. These things all pretty much have weird names. And what it says, it gives us a little story here. Shock, again, we are shooketh. We have $40 to spend on N gallons of gas. They're not telling us how many gallons we're getting. They give us a variable. So we've got N gallons of gas. Our gas costs $3.25 per gallon. And we know we have a total of $40 to spend. So we have 4 statements down here, some of which are equations and some of which are expressions. What's the difference between an equation and an expression?
All the words.
Not the words. All right, my turn to talk, guys. I'm hearing like 3 other conversations. What's the difference between an equation and an expression? I'm going to give you a clue. Up here, we have 2 of each.
Equation has an equal sign.
Equation has an equal sign. So our equations are going to be, well, yours are numbered, mine are lettered. Equations are going to be 2 and 4. And our expressions don't have an equal sign. I'm just going to renumber mine so it matches yours. So numbers 1 and 3 are what's called expressions. Equations we can solve. Expressions we can't really solve. We just can like kind of simplify it and mush stuff around. So what we're looking to do here is we want to see if we can figure out what they were trying to say in words with this math expression. So we know we have a total of $40 to spend on N gallons of gas. They're not telling us how many gallons we're getting, but that the gas costs $3.25 per gallon.
I mean, number 1 is just representing each gallon. Or each,
Almost.
the cost per gallon.
How much it costs per gallon times
The number of gallons.
times the number of gallons. So what is this going to tell us? If it's a number, how much it costs per gallon and how many gallons?
How many gallons you need. Or how much money we need.
How much money we're going to spend? This is an expression. I'm going to put expression here just because it's good for us to remember. This is an expression. And it tells us how much we will spend in total. So no matter whether or not I knew that we only had $40 to spend, I can figure out how much we're going to spend on gas by taking the cost times how many gallons. So what does this equation say? Number 2. Because this guy's an equation. Don't slap the rulers. What does this say?
That the number 2.
Mm-hmm.
That's the cost per gallon times a gallon equals
Mhm.
how many gallons you get, or how many gas.
This piece is awfully familiar, right? What did this piece mean?
How much was
How much we're going to spend on gas?
that equals how many gallons?
Equals, how much does it equal?
26
26. What is that 26?
How
gallons.
much money we're gonna spend?
How much money we're going to spend? This equation says we will spend $26. Could we figure out how many gallons of gas that would be?
Divide.
Yeah, if I took 26
Divided by
and divided by the 3.25, this that is 8. I'm gonna say this guy's. He's going to dead battery bin. We could solve this. When we have an equation, we can solve it to get to like an n equals or an x equals. I'm just gonna write it over here just because I don't have any space to write underneath it, but you guys do. Because we could divide both sides by that 3.25 and figure out to spend $26, it would take 8 gallons of gas, which is actually kind of a normal amount of gas. If you can find gas for $3.25. So these next two pieces are separate from this equation. It's not one continuing thought down the whole page. So there's pieces that'll come back. That first piece will come back again in a different one. But these are not like directly leading into one another. So we're not going to pay attention to this 26 here anymore. Because number 3, we have another expression. It does not have an equal sign, so this is an expression. And we want to see if we can figure out what the heck this is trying to be.
Yeah, I would say $40 minus
Mhm.
$3.25 for each gallon.
Yeah,
How much?
it's the $40 minus however much you spend on gas.
Yes, sir. There you go.
So it's how much money we have left, right?
Yes.
It's how much money, which I'm going to put a dollar sign because I don't want to write out the word money because I'm lazy.
I didn't.
Oh, the dollar sign? Or what? Yeah, I'm going to say it's an S with a line through it. How much money we have left after buying gas. It's our change. We walked in with $40, we buy some gas, I still have money in my pocket. This equation tells me how much. We have one more equation to look at on this one. So don't get mad at me when I do 2 pages, because sometimes one of them is short.
Why are we doing 2 pages?
Because this one took us almost 6 minutes.
Fair.
Because we only have one left to do on the page.
Fair.
So if we're doing more than 1 page, it's because they're short. So we got one more statement up here. What is that trying to tell us?
That is the equation for number 3.
Uh-huh.
Expression
It's our expression from number 3. So it's how much money we have left.
turned into equation. That means we have
And so it's how much money we have left is what?
$1.
$1. When we have $1 left. We could solve this and figure out how much gas it would take until we had $1 left. So if we were to solve this, it would be, I'm going to put our equation on here just because I wrote it for everything else. I'll put it down here. Equation. It's how much we could get and still have $1. Oh, I had more space. Yay. Zoomed in further than I thought. So it's how much money we could spend. We know that this expression we just talked through, this tells us the money we have and I took away what we spent. This says, when will what I have left just be $1? And again, this is something I could solve. We could try and solve this. I could take, I'm going to change my screen just a little bit. There we go. I'm just going to put it like that so we have a little bit more room. You guys have plenty of room. I just didn't have very much up here. If we wanted to solve this, to try and figure out how many gallons of gas we could buy and still leave with $1 in our pocket, what should we do first? How would we solve this?
Subtract 40.
We can subtract 40. Absolutely valid. I can minus 40 from both sides of my equation. Totally fine. We can do that. That's going to leave us with negative 3.25 n equals, what is $1 minus 40?
Negative 39.
Negative 39. I owe somebody money. But we don't want to just know what this is. I want to know what n is. What can we do now?
Divide.
Divide. We want to divide both sides by what?
Negative 3.25.
Negative 3.25. So negative 3.25. And you can divide by negative numbers. That's totally okay. When you do it in the calculator, we're just going to be really careful to use the correct negative sign. Because if you use this one, the calculator is going to give you an error. So the way we're going to type this one is we're going to have our negative. We use this one down here at the very, very bottom. 39. That's how the calculator knows it's a negative number. If you wound up with like ANS minus 39, you use the wrong minus sign. So negative 39, and we can divide that. Again, we got to use this negative down here. Negative 3.25. We can do that as decimals. We could buy 12 gallons of gas and still walk out of there with money. So our N would be 12. I could buy 12 gallons of gas and still leave with $1 in my pocket. I could go and get a little scratcher lotto ticket. Y'all can see the paragraph. Okay? So sometimes, even with these stories, we're not going to have to write our own equations. Sometimes we will, but sometimes it's just finding the pieces and trying to figure out what they mean. Because we're not always just going to have to write everything from scratch. Sometimes we're just going to have to evaluate things. Okay? Any questions on these ones? Okay.
Not hard.
The next one we're going to look at on the next page, page 81. We have several equations here. We are not going to be trying to solve them to get an answer. We are given a possible answer and asked to see if it's true or not. So what we're trying to see is, does this expression equal this expression specifically when x equals 2? So we want to know if x plus 2 is the exact same thing as x squared plus 4 when x is 2. How could we try and figure that out? What is x squared plus 2 going to be if x is 2?
Let's be x plus 2. Oh, wait.
If x is 2.
Oh, that's 8.
Here?
It's
4. It's a substitution thing. I could take this and I could say, okay, let's see what happens if x is 2. 2 plus 2. Well, we know that one. 2 plus 2 is 4. You guys have much more space than I do. I have very little space in here. If I did the same thing on this green piece,
That's 8.
I would substitute my 2 in here. 2 squared plus 4. And it's 100% right. We would get 4 when we do our 2 squared. 4 plus 4 gives me 8. So do these two pieces equal each other when x is 2? Is 4 equal to 8? Nope. These are not equivalent. Nope. This would not be a solution to this system. We don't have to solve these equations. You could, if you wanted to, solve these equations. Try and this has an x squared, so we would have to set it equal to 0, and then we would have to factor, and all kinds of that really gross stuff from Algebra 2 that we don't want to have to do anymore. We could try and solve this and factor it. We've done that before. That's Algebra 2. But I don't want to. All we care about is the specific point. So look at the next couple and see what happens.
Oh, they're equal.
See what happens on the next couple.
Number 2 is equal. What?
Number 2 is really similar.
So. are equal.
Because if I substitute in my -2 plus 2 on this piece, so substituting in this -2, we get what? What do we get when we substitute in negative 0? -2 plus 2 gives me 0. If I substitute in my -2 here, what do we get?
0.
0 again. Whenever we're substituting in, make sure you think about it being inside parentheses, because if I was to, in the calculator, do this and put just -2 squared minus 4 like this, calculator is going to get us the wrong answer. We have to have our -2 inside parentheses in order for the calculator to know that we intend for that to be -2 squared, not -2 squared. Because the calculator reads this one as -2 squared, where it takes 2 squared and then it does the negative. So if we went -2 times -2, we got to put it inside parentheses. The calculator is good, but it is not psychic. So it goes with what you put in, and it sees the negative as -1 times, which means our exponents happened before with the multiplication. So we love calculators, but we got to know how to use them, and that means whenever we're substituting, you want to put it in parentheses, especially if it's a negative number. Okay? Try the next one. So what we got? We've got our a equals 0 is the one we're going to try and test. We want to know if this mess of a fraction, a minus 5 and a plus 5, is going to equal 1. I'll write it over here because all my stuff's getting really smushed together. So we're going to take our a minus 5 and my a plus 5, and we're going to do our substitution. So instead of a's, I'm going to put in my 0, because they want to know what happens when a is 0. What do we get when we simplify this?
-1.
-1, because we get -5 over +5, which is the same thing as -1. So then the real question is, does -1 equal 1? Oh, sorry, just to clarify, this one was a yes. This one is no. -1 and +1 are not the same thing.
Which one is yes?
They're similar. It was the number 2.
Oh, yeah.
That was a yes. What do you think about number 4?
I'll do like that real quick.
I don't know. Take a peeksy peeks. To be fair, it doesn't have to be just you doing it.
No.
So here we're looking at our 5
That's
minus
no.
a and 5 plus a.
No. 33.
It's very similar. Not exactly the same though.
Like, get the same result.
Do we?
No, not the result. You get the same equation.
Do we? What's 5 minus 0?
5.
5. What's 5 plus 0?
Like, I meant, what's it called? Like, similar numbers.
Very similar numbers.
It's 5.
Yeah. It's 5 over 5. So here we get our positive 1. But they switched it on us. So this one still is a no. Ugh. If they'd had it as a positive 1, we could have done it. But this one they had backwards. So this one's also a no. But only because they listed it as a -1 here. If they had that as a positive 1, we could do it. But not this one. so look at the next one. See what you guys can come up with. What do we think on this last one? Do they match or do they not match when x is 0? They look real similar. What do you think? Substitute it in. Change my view again, just so I can write it out. Because if we take and substitute in that 0, we're doing our 3 times our 0 minus 8, and our 3 times 0, and then minus 8. So this one's almost getting into our equivalent expressions. Are they going to match? No, they're not. We could see that up here. We don't even have to do this substituting in because we can tell I would need to distribute this 3 over, and this is the same numbers, just not distributed. So these two statements are not equivalent. We can substitute the number in, or we can see this ain't gonna work ever. Never ever will this work, because these two statements are not equivalent. They don't mean the same thing. So this one's also a no. They gave us 4 no's and a yes. So it makes me wonder if this yes was special. Let's take a look at that yes one again. I'm gonna write it down here. And we had p plus 2 and p squared minus 4. So my next thought is this one special in that it's going to work every single time? Or did it only work for the one we looked at where it was p was minus 2?
I'm gonna go for that one.
Only it's going to work for this one. So they just happen to give us a solution here. What they're really trying to get at here is stop guessing. You get way more no's than we get yeses when we just start plugging in numbers. Because if we just start randomly plugging in numbers, we're going to get a whole lot more no's than we get yeses where they don't work. If we can figure out how they find these numbers, it's going to be a whole lot easier. And we're going to not do number 6 on this page because none of them work. Because they planned ahead well. Okay, so what we're going to do, we have almost 15 minutes left. We're going to do the little partner thing where I need you guys to do the paper so that I can pick your partners for a thing we're going to do next week. Okay, since we have time, let's do it now. That way tomorrow when we're done, we can just be done and have a relaxing Friday afternoon. Okay, so we'll do it today instead of doing it tomorrow, is my thought. So this is just you don't necessarily need to know everything on here. If we are just going on blind faith, that's fine. I'm going to use this to match you up with a partner who puts in a similar level of effort. So you turn me in something with just your name on it, you get a partner who also turned in something with just their name on it. So this is not a stress over it quiz. This is a give me what we can. We may or may not know what some of these things are because there's a couple of things on here we're going to talk about in the activity that this is about. It's kind of the point is think if you remember this from when you heard the word last time in Algebra 1 or 2. So this is the thing. I will use it to pick your partner. Whatever you have on it, what you're going to have on it, turn it in. There. Because I'm going to use this to pick your partners. This is a don't stress over it thing, but give me what we can. But don't stress over it. Okay, I'm gonna use this to pick apart. That's it. When we get to the end of the semester, I give them all back to you and you get to see how much you've grown over the year. But that way, when we have finished up tomorrow, we can just be done and have a relaxing Friday afternoon. Because we're only doing one page tomorrow, I think.